welcome everyone. Thank you for joining me this morning. Today I'll be talking to you about GraalVM in practice. We will be running R from Scala in a Spring Boot application at the Dutch National Police. My name is Perdijk. I work at CodeStar, which is a part of Ordina, a large IT consultancy here in the Netherlands. And today I'll be asking and then answering a few questions. Please come with. So the first question is, who am I? Well, as I said, my name is Perdijk. I am actually a historian and philosopher of science by training. I have a master's degree at the University of Utrecht in the history and philosophy of science. But after attaining that, I instead became a programmer. So I've been doing this for about 4 years professionally. I started out with Java, but I switched to Scala when that became an option. And I've been doing Scala ever since. I'm also a massive board game geek. So last weekend I went to Essen to go to Spiel, which is the largest board game convention in the world. And I was there for 3 full days. So it's awesome. If you like board games, you should go. That answers the first question. The second question is, why am I here? Of course, why am I here is the age-old philosophical question. Many philosophers have talked about this subject. And one that you probably know is René Descartes. And one of the things he said is, I think, therefore I am. Well, you can always reuse and reapply philosophy. So if we use this as an answer to the current question, we arrive at, I think I am here, therefore I am here. My grandfather used to say, if you ever do a presentation, please lead in with a joke. It doesn't have to be a good one. He also used to say to me, if you ever do a presentation, you might open with a personal anecdote. So that's 2 for 2. So why am I here? Well, last year, a colleague of mine, Jan Ouwens, went to give this talk at a different conference, a conference in Norway, called JavaZone. And as he was there anyway, he also decided to visit other talks. And one of the talks he visited was the talk by Oleg Sladjev. I'm hoping I'm pronouncing that correctly. And he gave a Java developer's introduction to GraalVM. And in that introduction, he talked about many things that GraalVM can do, including running foreign languages from the JVM. So if you ever get asked the question, well, why do you even go to conferences? What's the use of that? Please pay attention to this talk, because it's really about that. Well, that's the first part of the history, because, well, that's still not immediately relevant. The second part is that Jan Ouwens and I are working to digitize the Dutch criminal justice chain. There's a lot of paper involved in the criminal justice chain in the Netherlands. We're talking miles of archives per year. And we're working to reduce that paper load and also all the copying involved, etc. By using smart automation and also using data science to help process the large quantities of documents. Now, in order to do that, we're building a cloud-native application in the private cloud of the Dutch National Police, and we're using open source software only. It's got a front end, so the user can interact with it. It's got a microservice backend built in Scala, and it features real-time data science. So let me take you back to December 2018. This is a few months after Jan attended the conference in Norway. And let's take a look at the state of the application at that time. So we had a front end. It was built in TypeScript and Angular, always the latest and greatest version. It had a backend with event-sourced microservices. It was built in Scala using Axon for the event handling, Spring Boot for a bunch of wiring and to provide the services, Slick to talk to the database, and Kafka to connect to the data science part of the application. And the data science part at that time was a big monolith. So it was one giant construction created with R and a bunch of packages that were necessary to do the processing that we wanted to do. But not only did that monolith feature functional packages, it also featured a bunch of plumbing. So we needed Plumber to let that application have a REST API. We had to use Kafka to let it talk to Kafka. We had to use Docker in order to even get that thing off the ground. And it needed to plug into S3 because that's where we store our data, etc., etc. And it worked. It worked. I mean, it did what we wanted it to do. It was a bit slow though, and it would definitely be hard to scale. But this was locally. If we wanted to do data science in our private cloud, well, sometimes emojis speak louder than words. That did not go over well. Whenever it was deployed to the cloud, it couldn't find Kafka. It couldn't find Zookeeper. It would flood everything with Docker. It went to war with every single firewall that we had. And of course, being the police, that's quite a few. And it needed a bunch of custom installations and configurations before it still, well, refused to work. So we had a bit of a problem. And we had a few options there because our current data science, which we wanted to do real time, wasn't working at all, except when our data scientist plugged in his laptop. And that's not really a tenable situation. So we could either rewrite everything in Python, which was not a favorite because nobody on our team was any good at Python. We could also try to rewrite everything in Scala, which was good news for the developers because at least the developers know how to do Scala, but the data scientists were like, well, we'll have to learn a different language. And are you even sure that the things that we are doing are possible in Scala? But there was a third option that Jan had taught us about. We could just embed R using the Holy GraalVM. So this is the alternative title to my talk, GraalVM, putting R data science into Scala microservices. But let me first talk to you about what GraalVM is. So that's the new question. What is GraalVM? GraalVM actually consists of 3 different parts, and today I'll be talking to you about the truffle bit, because that's a universal virtual machine, and by universal they mean it speaks at least these languages. So that's definitely not all the languages, but as you can see, the 2 languages I've been talking about are named right there. If you want to know more about all the things you can do with GraalVM, I suggest looking at this article. But for us, number 6 was the big deal. So we could embed languages in a Java application, in a Scala application. Now, a very quick introduction for everybody who might not know. So what is Scala? Scala is a JVM language. So that means it can already interoperate with Java. It's very strongly typed, stronger than Java actually. It also has a functional outlook, so it's really good for if you want to do functional programming. But it's also object-oriented, like Java, so you can combine those two styles quite nicely. And has the upside that it's highly scalable, because if you do functional programming, it's usually quite easy to scale up. It features less boilerplate than normal Java, and it's also safer at runtime because it avoids using null, for instance. So what is R? R is a GNU project, and it's one of the go-to data science languages. It has lots and lots and lots of packages for data scientists to do all kinds of things. I mean, every time my data scientist comes to me and tells me about another one of these packages, I'm thinking questions like how and sometimes why, but it's really quite impressive. It can also be used to do functional programming, and it's dynamically typed. So unlike Scala, which is statically typed, our errors usually show up at runtime. But R does not run on the JVM. FastR does. FastR is actually a high-performance implementation of the R specs. So what the people of Grail actually did is that they rebuilt R using Java code. And that's what you're actually running under the hood when you're running R from the JVM. Now, to recap the old situation, we had a data science monolith. It had R plus all the packages that we needed to do our data science job, and a lot of plumbing. Now, we have, I think, about 11 or 12 microservices, which feature just the R packages on the R side. There's no more plumbing there. It's all gone. Instead, we use Scala to do that, because in Scala we already fixed all those problems that R was having in our native cloud. So we can now reuse that and even, for instance, share our logging tooling with R. I'll show you how to do that later. So for a quick overview, this is our, well, any of our microservice really. It's running in our own private cloud, obviously. I should not be using that because you don't see it, but the screen gets dark. And a message comes in from Kafka. It's deserialized by Scala. Scala makes sure that in the GraalVM context, logging is available. It makes it possible to write to S3, and it makes it possible to create domain entities. And then it passes the input that it has gotten to the FastR, where we do our analysis, and give back the results to Scala. Scala then serializes the whole thing and emits new Kafka messages for any further processing. And this works very well. We just have a bunch of small microservices, and well, it works. So was it painless? It was not. When we started doing this, GraalVM was still very much in release candidate stages. And we started with release candidate 9, and we went all the way through to release candidate 16 before we came to an actual full product. I see that the current version is listed as 19.2 on the slide. Looks like I forgot to update that. But it's a bit higher now, not that much, luckily. So it was very much bleeding edge when we started, and this is the blood that we spilled. So these are all issues that we submitted to FastR. that we ran into when trying to run R from our Scala code. And the first two especially were very big blockers, because at some point, fast R would turn an int vector into a double vector, and then it would crash in the next instance where it expected an int, which is, logical. You don't want to push a double into an int unless you really have to. But the point was we were giving it ints all along. So that was a bit of an issue. We also found some undocumented behavior from R itself in one of the associated packages. And basically all the orange ones are issues that are actual issues. The white ones, instead, are what I would call undocumented features. So the Scala tuple, and which is, well, a wrapper for just two values, would behave differently if you put in a third value rather than just two. Instead, the value would become a function, which means you had to use brackets to access it from R, and it took quite a bit to figure out that that was in fact the problem. And also, you might think that you can now let R files in the same jar talk to each other, but instead you have to do quite a bit of work for that, because the native source function from R can't be used inside a jar. So our verdicts. Let's start with the downs, because that's more upbeat. It's still quite bleeding edge. So this works quite well for R, but it might not work that great for some of the other languages that were listed. It's very hard to inspect the polyglot object. So whenever GraalVM makes a translation from Scala to R or back, it goes through a polyglot object, and it's quite hard to see what's inside there. And not all R packages are supported yet, but all the packages that we want to use are, so that's great. The ups are data scientists can now data science again. So instead of trying to do that data engineering role where they try to debug all kind of firewall issues, etc., they can now do the things that they are great at, which is extract information from large quantities of data. We can now also use a Scala from R. I'll give a short demo on that in a minute. And we can use R from the JVM, which means that we unlock a lot of options that we did not have before. So our general feeling on the subject is this is still very much uncharted territory. Now I see I'm talking quite fast, which means we'll definitely have time for the code. So let's get to the IDE. I'm assuming this is readable back there, because it looks quite large to me. I'm also going to take a small sip of water because I'm quite thirsty. So what we're seeing here is an application that I created together with my data scientist. And the awesome part is I only did the Scala parts, and he only did the R parts. And we needed very little interaction. I just told him I'm going to give your R code a PDF, and you do your magic thing. This is an example we made because we were both actually doing a talk on a conference at the same time. I was speaking at JavaZone, which is the same conference that we learned about this technology. And he was speaking at UL, which was in London. And let's see if I still have, I do not, because Mac does not want to help me, but that's okay. So this is the PDF that came with that UL conference in London. And it features, well, some words, obviously, but it also features a bunch of photographs. And the demo I'll be giving here is in fact about extracting all these pictures from this file. So they've been inserted into this PDF. And we'll be looking over all the pages. We'll be looking for squares, basically, which are made out of a different color than just plain white. And we'll be cutting those out and making them into separate files. And if everything goes all right, according to plan, then on page 10, the second picture, which is, well, this one, that's actually a picture of one of the data scientists. We should be able to find that. So back to the code. I'm going to start with a print line just to show you that, that I've actually started running it. And I'll then walk you through it, and then I'll just run it. So there's a Grail context here. This is what you need to access if you want to do polyglot programming. So you create a context, you tell it what guest language you want it to use, and well, you have to allow access, obviously, because otherwise you can't do the things you want to. And once you have that context, you can also tell it what sources to use. So there's a file analysis source here, which is basically just, again, you tell it what language it's using, and you tell it what resource it's using. So in this case, my resources map, I have a file called main.r. This is the file that is now accessible through using that source. Once you have that file, you can turn it into a function. So I'm saying this is a function from input analysis to unit. So if you see this in Scala, if you see that the end result of a function is unit, it means you're just doing side effects. You're not returning anything. You're actively stating, if you call this, I'll be producing a side effect. And the side effect will be that this output map will be filled with all kinds of files. So this is our file name. We can see that it's over here. And we use Scala to load it as a buffered input stream, and we convert it to an array, and we feed back that to the file analysis function. So there's a try here. You want to use try when you're accessing R from Scala. As I said, Scala is dynamically typed, which means that most of the parsing it's actually doing is it's doing it at runtime, which means it's quite likely to contain mistakes. And instead of having the whole application blow up, you might want to do something intelligent with that. So if you use a try, you can then match on it, and if it's a success, well, we don't have to do anything, but if it's a failure, in this case, we're just printing the stack trace, so might as well have thrown it. And this is what we will be feeding the R function. So there's an input analysis. It contains the file name, and it contains an array of ints, which will, the R side will be able to interpret as a form of data it can actually use. So we're now in the R code, there are two libraries in scope, Glue and PDF Tools. PDF Tools is the library that's, well, very useful if you want to do anything with PDFs. And for instance, we are printing the file name, and we are reading in the array as ints as a raw a stream of data. Now, before I bore you any further, I'm just going to start it because, as I said, I have not actually written any of the R code. So I'm just really giving a demo here for developers that I don't need to know what's going on here. I can just go somewhere else and we'll come back to this when it's done. So I have different demos in the meantime. Let's just run this one. We're going to print something. We're going to print it from Scala first, and then we're going to print it from R. So this is the R function that we call. We give it an input, and then it will just print it out. So again, this is the old conference. Let's fix this for future's sake. So let's run it again. And as you can see, it was actually printing from Scala first. Now it's parsing the R file. And once it's done doing that and booting up faster, it can actually print anything that we did on the R side. So this is very simple. Of course, I can also print stuff from Scala. So why do I even bother with this? But you can do quite interesting things. For instance, if you've done your logging setup for your Java or your Scala application, so something like this, except way more complicated, obviously, you can share this with your R code. So in this case, we'll be sharing the logging. So I'm going to print from Scala first, just to show you, well, there's a logger here. There's the context again. And if you access that context, you can actually put things in that context. So you don't just have the native R functionality there, you can also insert your own. In order to do that, you have to get the bindings, in this case for the language R, and then you can put things in there. And this is the name of the thing that I put in there. So it's called the Grail logger factory. And if I use Grail logger factory in my R code after running this, I'll get this object. So it's over here. And as you can see, the Grail logger factory has a get logger function. You can feed it a string, and then it will create a logger for that string. Here we are reading in the R function. So let's take a look at that. As you can see, it takes an input. Then it uses that Grail logger factory to get the logger, and then it parses in that string to get a logger for, well, whatever file it's putting in there. And then it uses that logger's info function to do the logging. So if we go back to shared logging, we can see, well, we have this log from R function. It's a context. It values this source. So the R run fun logs from R.R file. And again, it's something that takes a string and it returns nothing because it's producing a side effect, which is logging in this case. We also have, for symmetry, a logs from Scala function, and we'll call the Scala function first. Oh. And then we'll call the R function. So let's run this. So as I said, that's this log statement up here. And it's parsing the R file. And then we get to these two log statements. And as you can see, we actually have a functioning logger over here. So if we go back to this file, and instead we decide to log on warn, I am better off running this file, yes. So we run it again, and we've changed the logging level on the R side, and as you can see, it works. So that's really just the log4j logger that we create using a Scala function, but we actually call it from R, and we use it from R. So that's pretty nice. But there are other things you can do. So as I said, Scala is a functional language. Which means it can do a lot of interesting stuff. And you are probably familiar with .map as a function. So you can map over a collection and do something with every element in a collection. Well, in R, you have to import a package, and then it doesn't really, well, it's not very nice. But if you give it a Scala list, you can use the map function on Scala list. So here I create a list from Scala, and there are a bunch of strings in there. I mean, it goes on and no, wait, that's it. And so this is a list, and now I have this function I declare here, which goes from a list of strings to a list of strings. But it's not a Scala function, it's an R function. So let's take a look what it does. So it takes a Scala list of strings. It's of course dynamically typed, so you might put anything in there, but if you put something else in there, it's going to blow up. And on that Scala list of strings, it calls, this is actually a dot in Java or in Scala, but in R you use the $sign. And then you can access its members. So in this case, the map function, which you get default if you have a Scala list. And in that map function, you put a function that takes a string and uses it to create another string. So in this case, this is an R function that takes a string, and it uses the paste native ability to concatenate that string with R. So 10 points if you figured out what we will be printing here. So again, parsing the file. Once it's done parsing the file and you keep calling that file, etc., you don't have this startup time. But as you can see, it has actually taken every element of that string and it has concatenated it with R. So actually you can use the map function that Scala provides and then feed it an R function to manipulate the data inside. This is something that we actually use because it's more concise than the R alternatives, and also because it's really cool. But we can take this one step further. So if you have a collection in Scala, you also have a fold left, which means that you're going to iterate over that collection, and you are processing the elements of that collection sequentially based on the output of the previous operation. And again, there's this list of strings, and we are going to use the R function fun using fold left. It takes a list of strings, and at the end it will return a string. Now let's look at what it does. So Again, it takes a Scala list of strings, and now we use the Scala fold left method. We give it an empty string as a start, and then we use this append function to put the string that we have so far and then concatenate new element to it. So let's see if this actually works. And as you can see, it's now actually processed it as one big string. Now, what's interesting here is that actually I'm going through quite a bit of trouble here, because append takes two strings and pastes them together. But guess what also takes two strings and pastes them together? So I can replace this simply with the R native function of paste. I'll comment this out just to make sure. And if I run this again, we should have the same output. So that's pretty cool. You really can use functions from one language as input for functions for another. And that's quite powerful. You can do all kinds of stuff with that. Now, one last trick I'll show you before I show the result of the code I ran earlier is how to share a domain. So one of the issues that you can run into if you feature different languages in different projects is that you have to translate your domain object from one project to another. And usually you go through JSON or another serialization method. If you're actually using GraalVM, you don't have to do that. So I have a domain here. It's about weather forecasting. You can have this weather forecast, which features humidity, a wind forecast, sunshine, temperature, and the chance that it might rain or not if you go outside. And we can use this domain factory trick. Earlier, I showed you can share your logger with R, but you can also share anything else if you want. And I'm going to share this, this class, an instance of domain factory, and put it under the denominator domain. If we look at the domain factory, we see that there's a function called weather forecast. And if you feed it these values, it will create a weather forecast based on them. So we're exposing that to R. And, I won't bother you with this, but this bit is important. Because if we go to the R side of this particular demo, we have this. This is a data frame. And the thing with data frames is if you let GraalVM do the conversion for you, you're going to get a map of X to Y, which is really painful to parse. And if you don't parse it correctly, you're going to get an error at the location of parsing. That is not okay. But if you use the domain conversion that I'm going to use here, you do the parsing on the side where the information is available, so the R side. And if you make a mistake, this is also where everything will blow up. So there's this a magic file here that will generate our weather report. And then we use our domain object to create a weather forecast list. Then for every element that we have in the data frame, we're just going to create a weather forecast that actually fits in our Scala domain without going through JSON, etc. And once we're done, we can return it. So let me just run this. And as you can see, it prints out nicely. So what we're actually getting back are actual Scala objects of the weather forecast type, and they're all filled correctly. To show you what happens if perhaps the data scientist has made a mistake and put a wind scale in the humidity, we can run this again. Oh. Use more proper shortcuts. Thank you. Okay, so, oh right, that's true. This is what you get when you make last-minute changes. So what I did on domain factory is I created an overload, and now it's confused because it doesn't fit in either, so it doesn't know which one is correct, and therefore it doesn't know what to tell me. Okay. Okay, well, so much for that. I'm not going to debug that right now. If you don't use this functionality to share your domain, you can, of course, still use your results from R, but you might want to, might have to do something like this. So as I said, if you want to, if you get back a data frame from R, it's actually going to be a map of string to an array list of something. And in that array list, in fact, you'll also find another map. And once you have to go, once you want to convert that to something like that you can actually use on the Scala side, you have to do this. And this is just for the first 3 elements. There are 5 more. So that's not okay. Finally, so at the start of the demo part, I ran an R Scala project, and as we can see, it's created a bunch of pictures. And if I remember correctly, on page 10, picture number 2 should be the face of our data scientist. And it is. So the beauty of this is that I have gone to great lengths not to open these 4 files. So I actually don't know what the data scientist is doing in there. And the point is that I don't have to. I can simply provide the input that he requires, and as long as he gives me back the output that I need, we can cooperate inside the same team, inside the same code base, and inside the JVM. Well, so that was it for me. These are all my references, etc. And are there any questions? Are there any questions when I say you can get a stuffed toy for free? Yes. So you need GraalVM to run any kind of polyglot operation. But by default, if you install GraalVM, you don't get FastR. So if you want to run R using GraalVM, you have to install FastR separately. You can do that with tooling that comes with GraalVM. But GraalVM has quite a big landscape around it, so you don't want to drag everything in with a default installation. So FastR is a way to express R code on the JVM, and GraalVM makes it possible to even access the context and use FastR. Okay. If there are no further questions, one more. For a jump from Java or Scala to R, the performance bump is negligible. You don't even notice. For some R packages, because R likes to talk to lower level languages, sometimes in the R package, the communication between those two layers is very intense. So there's, instead of a single loop back and forth, they go back and forth a lot. And that is not good for performance on GraalVM. So that might be optimized for a native R, but in fast R that might be slower, while a single call in fast R is slower than using regular R, faster than regular R. So there's a trade-off, and it depends on the package that you use. So sometimes you have to work around the performance bottleneck. Well, if there are any further questions, please talk to me after this. Thank you for listening, and enjoy your day at JFall.